Dear learners, welcome to the first session of 6th week. The theme of the week is smart manufacturing and intelligent manufacturing. Smart and intelligent, both these words are commonly used not only for manufacturing but for other segment of the industry, whether it is a retail, whether it is a banking, insurance, education. But in this week, we will have a focus on smart manufacturing. And I will be discussing for other industries the smart concepts in the last week, that is the 8th week, in one or two of the sessions. In this week, I have planned 5 following sessions: introduction of smart manufacturing and intelligent manufacturing. Then in second session, we will go a little deep down of building block of smart manufacturing in form of a framework, connected workers, connected assets, connected plants, connected factories, and also a holistic view on the use cases of smart manufacturing, which will be guided by the use cases being used by global lighthouses of World Economic Forum. Then in third session, we will be deliberating the concept automation versus autonomous and how the technologies like robotics, humanoids and generative AI are playing the role in this area of automation versus autonomous. Then we will upgrade our knowledge on AI, how AI is being used currently in smart manufacturing. Basically, what is the role of agentic AI, what is the role of generative AI. So, various new concept of AI, sometimes it is called physical AI, in terms of robots, we will be deliberating in this session or fourth. And the fifth session I have devoted, I thought it is very important also to discuss about the smart supply chain and logistic, because they are connected value chain of manufacturing. So, this is the way I have built up this whole week syllabus. I thought let us begin with grand challenges in manufacturing, grand challenges as well as opportunities. So, strategies for sustainable, resilient and digital future of manufacturing. One of the important challenge which industry is facing last so many years is the decarbonizing the operation, because most of the industry, manufacturing industry, except industry like automobile, they end up generating some harmful gases in the environment, and one of the harmful gases is the carbon. So, you must be knowing as a student that we sometimes claim carbon footprints. So, industry is having a great focus how they can decarbonize their operation, what kind of technology they should use to decarbonize their operation. Whether some sort of digital technologies or AI can be also used, so which can give the prior warning about the carbonization aspects. So lot of successful implementations has been done across the industry, which has resulted into resource efficiency, maximizing output and while minimizing raw material input, material substitution, replacing carbon intensive material with the sustainable alternatives. Like we can see that the coal is being replaced by sustainable alternatives like solar. Coal is being replaced by solar energy. Energy efficiency, upgrading machinery and optimizing processes. Machinery also play a very vital role. What is the configuration of the machine, and the processes also play a vital role. So, new concepts of machinery and optimizing the processes. Sometime we try to re-engineer the processes so that the energy we can develop the energy efficiency processes excel. Fuel switching, this is another very important aspect which companies are trying to implement, transition to electrification and green hydrogen. That is because as we know that electrification and the green hydrogen kind of alternative fuels have very least impact on the carbon footprints. Carbon capture, on the outset of the fumes, there are technologies being developed to capture the carbons, and then use this carbon captures for some other kind of processing. We can call them the recycling or recycling of the carbon capture. And data standards, leveraging digital tools for precise carbon tracking. So these are the kind of opportunities are there in the industry, and any smart manufacturing industry is open to use these kind of options, or this kind of technologies, to minimize the carbon footprints, or to minimize the impact of carbonization due to their operation. Then we have opportunities in terms of challenges and opportunity in terms of supply chain resilience. Like we should there is opportunity for end-to-end visibility of the supply chain, so that we know that there is a bottleneck. This is also one of the important aspect of smart manufacturing. How and the connected value chain of smart manufacturing, the supply chain and the logistic. So here you can see on the right hand side, I have jotted down some of the technologies like technology enabled solutions using AI and blockchain for real time tracking what is happening, data integration, creating unified platform for supplier communication. So this is also very important when there is a data integration of one side we have a supplier platform, other side we have manufacturers platform, third side we have those logistic providers platform. If we are able to integrate all these three platforms under single roof or under single protocol, then there is a chance of having less bottleneck in the case of supply chain. So we will be achieving the resilience in supply chain. So this is a very important aspect of data integration. Then risk modeling, with the help of predictive analytics, we can do the modeling of the risk. We can develop the models around the risk, so that we can predict. We can predict what kind of risk is there, whether supply chain is going to be disrupted due to whatever the reason in the market. So this is another aspect which can be explored by any smart manufacturing industry. And the third and very important aspect is the technologies, novel technologies, which we have deliberated in other sessions of this course as well as, but we will have focused discussion when we will discuss about the smart manufacturing technologies. The smart manufacturing technologies, they are not different from the Industry 4.0 technology. They are similar technologies, but their use is somewhat different in the context of the smart factories or smart manufacturing. So here I have written over the collaborative platforms. So this is one of the new thing which is being promoted or is being advised to the companies that they should create the collaborative platform, creating network with the diverse research actors to bridge expertise gaps. So expertise cannot be obtained so easily. So across the value chain of the company, this expertise should be available on a collaborative platform. Technical assistance, we should use new technologies into legacy lines, so that technical assistance supporting the integration of new technology into legacy lines. This is also we will be exploring in the subsequent slides. I will be explaining about this. Then infrastructure investment. These are the opportunities which are very much there in the technology. So let us go deep down in the technology area or technology opportunities for smart manufacturing. Now in this slide, I am explaining the 6 core enablers for successful Industry 4.0 for smart manufacturing. So first, core enabler is the agile approach. Agile approach, employ quick iterations, fast failing and continuous learning. Agile teams transform bundles use cases in moves for rapid innovation and refinement. This is a very important to note that agile approach in case of smart manufacturing is one of the winning item. How we work with the cross-functional team, how cross-functional team collaborate to each other, and in case there is any eventuality of downtime or in case of any eventuality of the any downfall, how they collaborate and retrieve back the operation. Second, agile approach is very important. In case there is in the market there is a fallout, and where the industry is going to suffer, how you change in your strategy as per the market dimensions, or as per the market dynamics. That is also one of the agile, approach. What is Agile Digital Studio? Successful companies set up a digital studio for experimentation. Experimentation is one of the important aspect of digital transformation. So we should keep doing experimentation of different situations, scenarios, and try to be prepared for any eventuality where there is a change required. So agile digital studios are also one of the important aspect of the element of the smart manufacturing. IoT stack, we have already discussed about this in the second week of our course. This is a very important building block of Industry 4.0 and very, very important for smart manufacturing. All companies who are aspirant, who want to implement smart manufacturing, they have to implement IoT stack, which is a network of the sensors, edge computing and around the cloud computing in such a way that all the time real-time data, millisecond basis is available for the data processing, data capturing. IoT Academy is also very important. Many companies, who believe, in continuous learning, they have established the academy, some sort of, a baby school or, baby training center. They continuously keep learning new concept about the IoT, how they should innovate like technology. They develop the technology ecosystem, which we are going to discuss, in subsequent slide. And technology transformation office. This is also very important. Companies who are looking for transformation, developing from analog systems to the smart manufacturing system, they should have a dedicated office, a dedicated senior person and the team which is all the time looking how to, which area, which domain we should now in the factory should automate that, we should transform that, what kind of technology we should use, what kind of strategy we should use. So that is what the continuous research is required here, and that is being done under the roof of transformation offices. I have created this slide just to give you a glimpse about that, what all matters in case of smart manufacturing. So we will be discussing the connected and digital world in the second session. So very important that connected factories, predictive and efficient environment. This is also very important, which we have discussed earlier also, that we should try to create a predictive. Smart manufacturing work not on the yesterday basis, not only work on the today basis, they work on the what is the tomorrow, what is going to happen if the market changes, what is that going to, it believe in the predictions, if the equipment is going to fail, we should have a prior knowledge about that. So that is what, and that is possible with the help of AI and machine learning kind of algorithms. So that we have already. So smart manufacturing should adopt this practice of predictive analytics, AI predictive analytics and machine learning predictive analytics, and advanced analytics. That is one of the governing principles for the smart manufacturing. End-to-end visibility of the processes is very much required in case of smart manufacturing. How you establish that end-to-end visibility, that is something which is worth learning, and I will be sharing one of the example of my own company where I have worked. I have directed one very big project. How we could establish the end-to-end visibility with the help of a online system. Human-centric approach, which we will be discussing in the third session, that how we should now innovate a human-centric approach so that workers are focusing or spending their time more on the meaningful job, not on the mundane kind of job, repetitive kind of jobs. So in fact, the companies who are using human-centric approach or work robots, in some of the difficult situations, which is going to be earlier handled by the workers or labor, they are being considered as a human-centric companies, human-centric approach, and that is one of the principle of Industry 5.0. which we have discussed in the Industry 5.0 session in the fourth week. Similarly, sustainability, one of the aspects of in smart manufacturing is that we should try to minimize the waste, or we should recycle the waste, and we should use less energy, and we should use energy which is available in the environment, like solar energy or renewable energy kind of thing. That's why the word is giving renewable energy, more efficient resource. And then we should work for the business advantage. This picture shows us the technologies which are commonly used in the smart manufacturing industry, real-time data, AI analytics, connected machines, which we will be discussing in the next session, automation and robotics, which we will be again discussing in the next session, digital twin, we have already discussed in the 5th session of digital twin, 5th week digital twin, how they digital twins are being used in the industry. Again, we will revisit in the next session how digital twins are being used by the smart manufacturers. Skilled workers, this is a very important area for the success of smart manufacturing, that continuously investment in the workers to improve their skills, to upgrade their skills, so that they can perform on the new environment of AI or analytics, or robotics kind of things, and sustainability. These slides give us a glimpse about the future workforce, what kind of expectations securing talent are there for the future workforce. Bridging the gap, I have given the title called Bridging the Gap. Securing talent require a fundamental shift in perception and training. The talent require, today the workers require something different, something their attitude, their mindset has to be on the learning, continuous learning. So employer training tries building strong relationship between industry and educators or academia, on the job learning, perception, diversity, these kind of things are required. In fact, I will try to run a small brief session on about the future workforce in the coming week. This is a master slide where I explain that after knowing what we have discussed previously in 4-5 slides, if you like to build that smart manufacturing, what all things will matter, what all you may require that. One is that you need a core, the production systems, we call it that the factory, the cyber physical production system, where physical processes are controlled by computers, constantly communicate with each other. So you should have a replica of your physical process. Suppose there is a machine or there is a furnace, which is a part of the factory, the replica of the furnace should be on the computer. It should be whatever event is happening in the furnace should be also reflected on the image, should be available, visual image on the real time basis available on the computer. That is the meaning of the cyber physical system. This is a very important aspect. If any industry who says that I am a smart factory or a smart manufacturing, they should have this kind of technology available. Real time decision making, modularity is easily adapted production line to switch between different products. Modularity is also one of the important aspects. It's not like that. If you want to change your production line, you have to bring down the entire production and then you switch over. No. You should be switch over on the running plant. That is what is called the modularity, interconnected ecosystem, where you are connected, is Internet of Things. So everything is connected in your ecosystem. Data, all your all your equipments. And all the time, people are connected to the factory. What is happening in this machine is called connected environment. IoT also we have discussed about that. So this is all is required for building the smart manufacturing. On the right hand side you see different versions of smart mobility. You see here smart buildings. You see they also work on the similar principles, which I am not going to elaborate over here. But if somebody says that you are talking about smart manufacturing, what about the buildings? What about the logistics? They also are equally whatever concept we are discussing here. These are also equally applicable to all these domains, like smart mobility, smart buildings, smart home, like that. This is another picture of the technologies which are in use for smart manufacturing. We had already discussed about that. And here we are seeing some application of these technologies like automation and robotics. Physical and software robot work autonomously. You can see in the first picture. Then sensors record physical condition and transmit signals. So knowledge about all these technologies along with their application is very much required if somebody is working on the smart manufacturing concepts. So in this slide, like 3D printing, optimized manufacturing using additive processes. So you need not to all the time, go back to the drawing board and you have to develop that pilots, and then you develop after the pilot is successful, then you develop the commercial. In case of 3D, once you have the 3D picture available with you and you are clear about the what is the raw material, and you are clear about the process of the 3D, then you will be able to manufacture that end products in one go. So these are the technologies which are very important. The last thing which I will say, that the platform and application leverage specific industrial solutions. Here again this is something which is industry specific. Suppose somebody is working in the steel industry or somebody working in the power industry. So for them the platform will be different. So you have to thoughtfully develop these platforms which will cater the need of this platform. In fact act as a backbone for all these industry implementations. All these kind of technologies which we discuss. This platform provide the backbone for running of these technologies or interfacing these technologies like that. I will be discussing the Tata Steel case study as part of this session. There you will see that how they are using the platforms. So I have shown here a big picture of the robotics and humanoid technologies, which we will be explaining in the third session. But I thought for sake of completeness, smart manufacturing largely today are using humanoids instead of robots. 10 years back we were having very big use of the robots, but now humanoids are they work for a specific task like a human, and they have a precision, and they can work 24/7 like humans are not. They are allowed to work 8 hours or 10 hours. Their capacity is not more than 10 hours, but robots can work 24/7. So this is the way industry is getting advantage of these technologies, which we will be discussing in the third session. So now I come back in the next 5 minutes about how Tata Steel is using this concept of smart manufacturing. 3 plants of Tata Steel has been recognized as a World Economic Forum as a global lighthouses. So you know about the global lighthouse. We have already discussed in the 4th week. Tata Steel success demonstrate the digital mastery require a vertical and horizontal digitalization and standardization platform approach, most probably a 3-stage commitment to people transformation. We will see that how they have done. So this is the technology at scale in Tata Steel, which I have taken one of the case study of Tata Steel, which was published in Harvard, and this picture I have taken from the Tata Steel case study published by McKinsey. You can see that how they are working on the digital platforms, or how their entire operation is being governed by this kind of visuals. So what are the key initiatives of Tata Steel? Tata Steel established an advanced technology ecosystem for operation excellence, cloud and scalability, AI and machine learning in production, real-time detection and automation and agility. This is a picture which I have tried to customize based on the discussion and talk given by their CIO in one of the forum. And if you like to listen to the talk, this is a 35 minute talk. It is available on the YouTube. So what is the gist here? If you see in one go how Tata Steel is using technology platform and how they are transforming the technology for business outcome, this is the picture which will guide you, which will give you this information. Like you can see here, one is the bottom line is their infrastructure platform, which they have established very strongly. They have a sensor network, network connectivity all across their plant, and they are using cloud, internal cloud mostly, and they have a very strong policy of the cyber security. This is their bottom line. Then in the midline you will find here data platform which they have established, which cater the all need of the AI, and they have data from all sources of their plant operation, plant machinery. So the data platform also they have invested very heavily, and then they have developed the insight on top of that. And insight is such a great thing they have developed. They get the insight about their production quality. What are the pain areas? What are the some pitfalls in their production? If any product is not as part of their specifications, then the insight platform will diagnose the reason for that, and then give a prior warning. So this is where and you can see on the right hand side, on the third column. This is the third column. You can see what are the impact of all these initiatives. Like infrastructure has compute 80 to 85%. Their computation is done on the cloud. 40% of IT spend on the foundation and 33% on the sustainability, and 27 for on the transformation. This is the kind of aspect. Rightmost side, you can see that their focus is on the simplify the infrastructure, synergize data platform for all sort of operation. Data platform sit in between the infrastructure and the insight platform, and then scale at large. This is another picture which I have tried to made out of this talk. These are the three basic building block of their technology led business transformation: cloud, data, and AI. And this is what they recommended for any smart manufacturing initiatives by company. One of the important things which all these companies are facing, which want to build a smart manufacturing, is the legacy backlog. BKC backlog. And how these companies like Tata Steel has overcome this legacy backlog is one of the great learning. So unless we are able to know about the legacy applications, how we retire them, how we use them through microservices and API network, it is very difficult to come on the smart platform or smart manufacturing. So this is again a good lesson for anybody who wants to migrate to smart manufacturing, that how you overcome the legacy applications or legacy backlog. So this all I wanted to cover. Now I am preparing with this slide that what we are going to discuss in the next session. What is a smart factory or a smart manufacturing framework? It has basically three layers. You can see one of the layers is called attributes. Then we have to build the capabilities, and then third layer is the enablers, which are those enablers. So now we are going to deliberate in the next session all these three layers before we go ahead for any other discussion. Thank you very much. I hope you would have understood this fundamental concept of smart manufacturing, and we will elaborate further in the next session. Thank you very much.